Miss Lee's Chemistry Academy, Lab 6, a kinetic study of crystal violet reaction. Investigation. In this investigation, you will need to design experimental procedure and perform graphical analysis to determine the rate law of the fading of crystal violet in its reaction and aqueous sodium hydroxide solution using Beer's law. Chemical principles. When crystal violet reacts with sodium hydroxide, the color will fade with time, producing a colorless product, CvOH. The reaction is shown below. A colorimeter set at a wavelength of 590 nm is used to measure and follow the disappearance of Cv in its reaction and sodium hydroxide by measuring absorbance versus time. The rate law is shown below. Chemistry principles. A reactant ratio of 1 mole Cv plus to 1,000 mole of hydroxide ion or greater is used so that the hydroxide ion concentration remains basically unchanged while Cv plus is a limiting reactant. Replacing the two constant values of K and concentration of hydroxide, a pseudo-rate constant can be written as shown below. A kinetic study can be conducted by monitoring changes in crystal violet's absorbance as it is directly proportional to concentration. Rate determination by graphical analysis. From the data collected in a standard calibration curve of absorbance versus concentration of Cv, and in the reaction graph monitoring absorbance versus time, an integrated rate law describing the concentration of Cv as a function of time can be obtained using graphical analysis. The resulting linear plot is used to identify the order of the reaction with respect to Cv. As represented by the exponent term W of Cv, concentration in the rate law. Procedure. To start this experiment, you must create a standard calibration curve. First, prepare a set of crystal violet standard solutions consisting of 10 ml each of a 5, 10, 15, and 20 mm Cv solution using a 25 micromolar Cv stock solution according to the following volumes. Standard solutions of crystal violet. This photo shows the 5 different Cv solutions which differ in concentration of Cv, which impacts the intensity of the purple color. Procedure. Determine the absorbance values of the set of crystal violet standard solutions in a colorimeter at 590 nm. The photo below shows the 5 solutions of Cv in cleaned cuvettes with lids, as well as 1 water solution that is used to calibrate the colorimeter. Procedure. React 6 ml of 25 micromolar crystal violet solutions with 4 ml of 0.2 molar sodium hydroxide solution. The calculations for the molar ratio is shown below. Follow and record the decrease in absorbance of Cv during its reaction with NaOH as the color fades with time in a colorimeter. Then perform graphical analysis to determine the rate order with respect to concentration of crystal violet. Color fades as crystal violet reacts with NaOH. The photo on the left shows the Cv and hydroxide solution early in the reaction when the color change is very minimal. The photo on the right shows the solution after a longer period of time when the color has faded more drastically. 1. Standard calibration curve of Cv. This graph shows the linear plot of the absorbance versus concentration of the standard Cv solution. 2. Absorbance versus time, reaction of crystal violet with NaOH. This graph shows the absorbance of Cv solution mixed with hydroxide versus time at 590 nanometers. Graphical analysis. Use log or pro to calculate values of the natural log of the concentration of Cv and 1 over the concentration of Cv in order to generate the 3 graphs of the following measurements. Or extrapolate data sets of the concentration of Cv and time as x and y coordinates that correspond to the same absorbance values from the standard calibration curve, graph 1, and the reaction curve, graph 2, to plot the above 3 graphs. 3. Concentration of Cv versus time. This graph shows the concentration of CV versus time, which produces a negative curve. Natural log of concentration of CV versus time. This graph shows the natural log of the concentration of CV versus time, which produces a negative linear line. 1 over concentration of CV versus time. This graph illustrates the relationship between 1 over the concentration of CV versus time, which produces a positive curve. Conclusion. The linear relationship of the natural log of concentration of CV as a function of time in graph 4 confirms that the reaction is first order with respect to CV. The rate law is shown below with the slope of the line. Error analysis. When creating an accurate standard calibration curve, the volumes of crystal violet solution and water pipetted in preparing the standard solution need to be accurate. If they are not, then the curve will be incorrect, which will cause errors in the calculations. Some errors include leaving fingerprints on cuvettes, which will increase absorbance and result in less accurate pairs of crystal violet concentration and time data. As the slope of the linear plot is altered, the rate constant K will be less accurate. Also, once the reaction of crystal violet and sodium hydroxide has initiated, there should be less time delay in filling and placing the cuvettes into the colorimeter to follow changes in absorbance versus time. This will ensure that the concentration data is paired accurately with time data to produce an accurate linear graph.